Hi, my name is Steve Rahi. I am a Premier Field Engineer specializing in System Center Technologies. Today's discussion is part 2 of an ongoing series discussing Configuration Manager 2012 operating system deployment. Today's discussion will center on the mechanisms and tools that we have available to us to obtain an image. We obviously need to obtain an image before we start to talk about deploying it, so we will go through that discussion. So as we work through this topic, there will be some things that kind of touch on topics that we'll detail further as we go along. As an example, you'll see me talk about task sequences just very briefly in the discussion today. Not with any detail. We will put the detail around the task sequences as we move on. You might hear a few other terms just because things kind of tend to interweave a bit as we go forward without really unpacking things. That's kind of intentional. We'll do that unpacking as we move along through the series. But today's discussion is totally centered around the options we have to capture an image and import it into the console so that we can begin to prepare for imaging. Right, so here's the agenda. First thing I want to talk about is the reference image, then talk about some of the Windows tools that we can leverage for imaging, because remember, at the end of the day, all that OSD really is a merger, a marriage, if you will, between the Windows setup tools and Configuration Manager, and allowing the union to be really orchestrated very well because of the wrapper that we put around it and the logic we can put around it and that kind of thing, right? Then I want to talk about capturing the reference image using tools that you'll find commonly in use in the world today, MDT and OSD. Then I want to talk about the install.wim file, using that directly, some of the implications of that, and then we'll wrap up by showing you how to actually import the captured image into the Configuration Manager console. Okay. So in terms of getting started, the reference image, obviously the reference image is very important in order to have something that you can deploy to the environment. The question is, how do you want to deploy it? Are you going to use a thick image approach? Are you going to use a thin image approach? Are you going to use a hybrid? The decision you make will definitely impact the kind of actions you will take in Configuration Manager. Certainly, if you want just to talk in terms of simplicity, the simplest, you could argue, would be the thick imaging approach, right? And certainly we can accommodate that in OSD. The thin imaging approach is the most dynamic and the most flexible, right? And then hybrid is somewhere in the middle. So the chart that I list here just talk about the tools that you can have available to you to deal with and obtain the images that you might need in various scenarios. So all of them are in common, you'll see, between thick, thin, and hybrid, except for install.wim, right? And I just call that out because install.wim, as we'll talk about a little bit later on, is the base load of an operating system from the DVD media, right? It doesn't have anything in it. It's just what you would expect if you were to put the DVD into the system, the CD-ROM drive, whatever DVD drive, and load it. So the install.wim really is the ultimate in a thin image that you can obtain and leverage very easily, very quickly, without having to worry about capturing anything. Right now, there's some challenges to understand about the install.wim, but it's really a neat approach, right? For the rest of them, the ADK tools, we leverage those extensively for imaging. We can leverage them directly. We can leverage MDT. We can leverage the OSD image capture process, which we'll see. And then there's another way called build and capture, right? So when we think of imaging, what's the best way to stage an image, right? You either have one of two choices when you think about creating an image. Either you're going to do something like use the install.wim, which is already a WIM file, which is what we need to install, or you're going to have to capture the WIM file, right? Whether it's by using the build and capture task sequence or having a reference image that you build by hand, whatever, you're going to have to capture that if you're going to image. So if you are needing to capture, the question is, what's the best platform to capture on? Is it the physical system that you're intending to build, or would a virtual machine work just as well? The answer to that question, frankly, has changed a bit over time. It used to be that the physical machine was not only preferred, it was really necessary, right? And that really is in the days where we had an image library of images that we would have specific to the model of hardware that we're trying to deploy on. That's how we used Ghost and things. And you could, in theory, do that in ConfigMgr. It's really not necessary, especially now that we're past Windows XP with the hardware abstraction layer. There's really very little reason to have more than just a generic base image that you can deploy across all sorts of different hardware platforms. So for that reason, to keep all of the complexity out and the uniquenesses out of the base image, using a virtual machine is a really elegant, very easy approach because it's a VM. You can run a VM on any platform that hosts virtualized capabilities, Windows 8, Windows Server 2012, VMware, whatever, right? So that's what we'll do here, is we'll leverage a virtual machine to do the image capture. Okay. So real quick, as we start to talk about the image capture and envision what it would be like, again, just to bring the point home, what we're doing in OSD is really nothing that you couldn't do outside of the Windows tools manually. Right? I'm not going to spend much time on this except to highlight that you could do this manually, and I'll show you quickly a tool that could be leveraged to do this, right? But that's about it, because the main focus is I want to talk about OSD. If you were going to capture an image manually, you would need to use a combination of Windows PE and the automated deployment kit tools. Right now, why do you use each one? So really, the process that you would work through, which I'm going to short circuit when I demonstrate this to you a bit, but if you were going to capture an image, the first thing you would want to do is sysprep that image, right? Generalize it, get it ready, generic, make it generic so that you can redeploy it. That's a requirement. So I'm going to skip the sysprep process whenever you see me do this, right? But after you do the sysprep, the next thing you would do is reboot into Windows PE. Right? The question is, why would you reboot into Windows PE? Well, it's very simple. Whenever you're creating an image, you don't want the hard drive that contains that image to be running and have that image mounted. You want to have that image idle, so that your operating system that is running is totally in RAM. And that's what Windows PE is. It runs totally in RAM and can access the hard drives and such and manipulate the data, pull the data off of them, whatever. And that's what we're after. So that part, the image capture, will run in Windows PE. And then after or when we do the image capture, there's a couple of tools that we could leverage out of the automated deployment kit. Two tools that you will see commonly referenced. ImageX is the one that kind of started it off. That's one I'll use today. And then a tool called DISM that can be used as well for image capture. Right? So again, not going to spend a ton of time here, but let's go ahead and pull in a machine and take a look. All right, so as I pull it in, you'll see Windows 8 running here. Right? So what I'm going to do immediately is just go ahead and turn it off. What I would normally do if I really cared to capture this the right way is just run sysprep on this system and then shut it off and reboot into Windows PE, right? A couple of points. So sysprep is the first piece, and then you also need to have the system in a workgroup configuration in order to capture it, not domain joined, right? So I'll go ahead and turn this off, and then I have already mounted in the DVD drive a Windows PE boot media, right? So I'm just going to use, oops, sorry, I do not. I need to change that. One moment. I'm just going to leverage the boot media that I create in ConfigMgr because while it's customized for ConfigMgr, it is also Windows PE, and I can easily leverage the tools that are in PE to get my job done. So I'm going to boot from the media here and give it a second to load up, and then we'll just walk through an example of capturing an image using just the tools directly. Alright, so we're far enough in. I'll just hit F8. Again, what goes on behind the scenes I don't care about now. In fact, I'll just cancel this. Doesn't matter. Just a note, right? You see that I have the command prompt up. That's possible because I've enabled, well, let me just go ahead and show you. I've enabled command line support in the boot image, or yeah, in the boot media, right? So because I've done that, I can access with F8 and get to a command prompt. So if I go to the boot media, go to properties, and then look at customization, I've enabled command prompt support, right? That's why I'm able to get to the F8 prompt, or I'm sorry, the command prompt using F8 on the keyboard. If I hadn't had that, I would not be able to do that. Here's another tidbit. So you saw me cancel the wizard behind the command prompt whenever the command prompt came up. If the command prompt were not up, the system would have rebooted then. But because the command prompt's up, the system does not reboot. Right? Just a couple of tips. All right, so I at this point have removed my machine from the domain. It's in a work group. I've also run sysprep in preparation for this, and now notice that I'm running on the X drive. Right, so that's my RAM disk. It's not using the local hard drives at all. If I want to know what the local hard drive configuration looks like, easy enough. I can just pop in the disk part, take a look, and this disk will show me I just have one disk, and if I wanted to list the volumes, list vol, will show me that I have 3 volumes here, D drive, C drive, which I'm going to capture, and E. Right, so I'm going to exit this. And then to capture it, I'm just going to change directory to Package Manager. And again, not every piece of PE maybe has all the pieces of the ADK that you want. This one does. It's very convenient. That's why I use it. All right. And there's a tool in here called ImageX. There's a number of tools in here. DISM's in here as well. I'm going to tell it to capture, and I want to capture the C drive. Oops. One thing I need to do before I do this. Sorry, I need to map a drive. This is a network location where I'm going to store things. So you generally will not want to store the image on your local system. You'll want to put it on the network somewhere. So just going to map to the C drive. And that should go through. Good enough. Now I will run ImageX capture to Z:, and just call it ADK capture.wim. And I'm going to name it ADK image. Right? And it will go through and start the process, and off it goes, and that's all I really care about. Just to see it starting, I'm not going to even keep it around, right? But you saw, it starts the process, it starts scanning the drive, it starts creating my image. And so if I actually got far enough in this, let me pull the environment back in here, you should see that I've gotten a little bit of the ways toward it, enough to create the file, assuming I let it run long enough. Looks like I didn't, but you would have seen it pop up here if I would have let that run long enough to create the file, the WIM, and off we go, right? So easy enough, very easy to do it with the ADK tool should you choose to do that. So let me move this back out and we'll just continue here. All right, but most of the time you're going to use the ConfigMgr tools or the available tools to be able to obtain your image, right? So what are those tools? You're really going to hear 2 tools mainly talked about when it comes to ConfigMgr and image capture. One of them is MDT, Microsoft Deployment Toolkit, and the other is OSD itself. So the question is, why would you use one versus another? And the debates on this will rage. If you pull in a couple of deployment folks and ask, you might get varied answers as to which one is better and which one they prefer. And it really illustrates a lot of the power and flexibility of ConfigMgr, because there are a number of ways that you can get some things done that you might want to do, and it really depends on what you're trying to do, which one is going to best suit you, right? So in terms of MDT image capture versus OSD image capture, both of them are going to result in a deployable WIM file. So you remember from our first discussion last time in session 1 that the image is contained in the WIM format, Windows Image Format, right? So whatever image capture tool we leverage needs to ultimately produce a WIM. because that's what we deploy. So both are deployable WIMs. You can do the same with each one. Both ultimately are going to be equivalent in what they deliver for basic image capture. So what is basic image capture? So basic image capture would be that scenario where you stage your machine manually, maybe build a reference machine, and then capture it into a WIM, and that's really about it, right? So basic image capture. And ultimately, however you do this, whether it's MDT or OSD, both of these approaches are going to require a manually built reference machine. Now, I'll twist that a little bit in a minute whenever I talk about build and capture, right? But if you're going to capture an image, you're going to have to build it. Outside of build and capture, you're going to need to manually build it by hand, right? And customize it, which brings in all sorts of potential for human error, wasted time if there's a problem, that kind of thing, right? So while this works and it's good and a lot of people use it, there are better approaches that we'll talk about later, all right? Okay, so in terms of MDT itself, what are the advantages of leveraging MDT? So in terms of basic stuff, they're about the same. There are some advanced image capture capabilities in MDT, right? So one of the things to understand, whenever we are in the process of capturing an image, right, part of that happens in Windows PE, part of that happens in the running OS, right? So MDT is different from ConfigMgr OSD image capture in that it will log on to the system as an administrator. That and OSD does it as system. I'll mention that again in a minute. That offers some interesting advantages because as administrator, for example, if you tweak your profile, whatever, you can save that off. And in fact, that's one of the key things that you will notice that people talk about MDT is the ability to capture the default user profile, to tweak it live and such. The way that really works is through the ability MDT gives you to pause the image capture process at a certain place while you go in and make some manual adjustments to the profile, customize the profile, whatever, and then pick back up and resume the image capture. If you're interested in that kind of thing, a really good article that talks about it is right here, and you can go and look at it. It talks about the possibilities and process with MDT. It talks about how you can do the same thing ultimately with OSD, but this pause feature that MDT has in it is really attractive to some folks to be able to go in and manually make changes, right? My personal preference would be to make those changes in automation so that they're documented so that we know what's actually taking place, right? But you can do it either way. There's also a perceived ease of use compared to OSD. Really, that perception doesn't really lend itself so much to reality. MDT and OSD are built on the same engine, the task sequencing engine. They go about doing their jobs a little bit differently because MDT is standalone. And so there are some different configuration files, a different look and feel. Essentially, though, it's very similar, right? OSD is very similar in terms of the kinds of things that you need to do to get an image deployed. There are some additional complexities because OSD is part of ConfigMgr, which is itself a complicated product. But with OSD, you can take advantage of the ConfigMgr scheduling and reporting and bandwidth control and all these things that with MDT you don't have, right? Another item that folks talk about with MDT is the ability to do software updating by specifying a WSUS server that you can pull the updates from. Again, with ConfigMgr, it's kind of a wash because we have our own WSUS server that we can deal with and so on. So the main thing, really, where MDT has some notable difference with ConfigMgr is the ability to pause and customize the profile and that kind of thing. Besides that, it's really similar, right? So there is, as I mentioned, a different look, and this really isn't about trying to talk about MDT so much, but I do want to show it to you so that you can get a sense of what MDT looks like. All right, so let me go and connect to it. So here's my MDT server. You pull it in here. And MDT is driven through this console called the deployment workbench, right? Here's our task sequence, and task sequences drive all image deployment, including in OSD. Oh, I'm sorry. Task sequences drive all image capture, including in OSD. So what I have here is just a sample task sequence I built. Let me show you the wizard first, and we'll look at that. So for task sequences, we can create a new task sequence and give it just a couple of ID values. We're not going to save this, so call it test. And then this wizard will let you build the various task sequences based on templates that are available in MDT. So here you can build a custom task sequence in MDT just like you can a custom task sequence in ConfigMgr, and the one we're interested in for building or capturing a reference machine is this one called sysprep and capture. The name, as it implies, we're going to sysprep the image first, reboot, capture it in Windows PE, and we're good, right? So again, not going to spend a lot of time here because we're going to spend more time over in OSD. But here is the task sequence that the wizard generated, and this is a list of tasks that we would go through in order to capture a reference machine that was already built, right? So just a few of the highlights. So here we're going to make sure that the sysprep files are in place. Most of the, or all of the more recent operating systems had the sysprep files in place already, don't need to copy them, but XP, as an example, did not, so that handles XP. Other things, we're going to go ahead and execute sysprep and take care of that, and then once we do that, we're going to load down Windows PE because that's what we need to boot into, and then we're going to again apply Windows PE, the BCD part, restart the computer so we get into WinPE, and then finally we're going to create the WIM file. Right? So that whole process that we talked about just done automatically. All right, so let's get MDT out of the way, and we're not going to spend any more time there. So let's just go back to the PowerPoint. All right, so that is a list of what, or at least an overview of some of the things that MDT can do for you. That is different than what OSD can do. Again, OSD can do most everything that MDT can do, just might do it a little bit differently, right? So let's focus on OSD for the rest of this. So in terms of advanced image capture for OSD, how is it different? What are some of the advantages? So one of the things I mentioned before for MDT, we can log on as an administrator interactively with the user profile. With OSD, it's engineered not to allow that. Specifically, everything OSD does is done as the system account. Right now, there's going to be some exceptions. There are going to be some steps inside the task sequence wizard that will allow you to use other credentials, and there are places that other credentials come into play beyond that even. But the work of the task sequence is done in local system. Vast majority of lion's share of it, unless you specifically have a task that allows you to do something different. Right? With OSD, you have full customization that's possible with the task sequence. Now, you can fully customize a task sequence with MDT as well, but through some of the cool customization steps, right? Well, contrast it this way. With the MDT user profile kind of thing and those kind of manual steps that you might do when you pause the task sequence during the capture process, you can customize all of those through the task sequence. The real advantage of that is that you take the manual effort out of the process, and instead you allow the system to automate the process of deploying whatever it is you want and capture from there. Now, that is something that will happen if you do something like a build and capture, which we'll talk about more in a minute. Right? If you use the native OSD image capture approach, you don't have to worry about having another tool to learn, having another tool to maintain, and so on. The build and capture you've heard me talk about several times. OSD offers that as a native option, a template, if you will, that you can build. We'll look at that. You can do the same kind of thing, ultimately, with MDT, but it's not a pre-built template, all right, like it is in OSD. All right, so build and capture, definitely an advanced image capture kind of scenario, but brings with it some really cool things. And then lastly, zero touch image capture. So the idea being, the whole idea of OSD is that there is zero touch. In 2012, it's actually gotten a bit more flexible to allow light touch because some scenarios and some customers really prefer that. But when OSD was envisioned, it was envisioned as a fully zero touch image capture. The benefit of that is fully relying on the automation to reduce the potential for human error. Also, if you put all of the detail of what's going to happen during an image build, image captured, image deployment even for that matter, inside a task sequence, you essentially kind of have a self-documenting module, if you will, to tell you how a machine is built. There's no guesswork. There's no human error. It's built the same way every time. If you need to make a modification, then you make a modification in the automation. But I'm jumping ahead of myself. All right. Okay. So let's look at the image capture with the OSD capture media. Again, this is kind of just the simple approach. And we'll first pull in the ConfigMgr console to look at building the capture media. So if we look under task sequence, right click, we have two options: create task sequence and then create task sequence media. In OSD, the task sequence media is essentially a Windows PE image that will allow you to do certain things. In some cases, it's building a reference image. In other cases, it's deploying, and so on, right? So we have standalone media, bootable media, both of those for deploying an image. We have pre-stage media, this one also for deploying an image. The one we care about is capture media. Okay, so we can hit that, click next. And before I do that, though, this wizard is going to create an ISO file that you can then put into a VM and leverage. That way you can burn to media, you can burn to USB drive, whatever, and leverage. One thing that I don't want to forget to mention here. So whenever you look at MDT, you saw the sysprep and capture. It was a template that resulted in a task sequence. The capture media also results in a task sequence, but you don't see it. It's embedded in the ISO. It's for the specific function of simply capturing the image, right? So there's no customization available in the basic capture media. But you won't be able to see the task sequence in it. Whenever we get to the next one, build and capture, you'll definitely be able to see the task sequence. And it's kind of akin to MDT in that way, although the capture media and the sysprep and capture template in MDT are really the parallels here. All right, so I click next. I can tell it what I want to build, so I'll just call it /capture test.iso. I'm not going to build this, but you'll see. Then I choose a boot image, right? So remember, the goal of this, all of this is going to get us into Windows PE to do the capture. The boot image is Windows PE. What Windows PE boot image do you want to use? So I'll just choose the Windows or the x64 boot image and go from there. Little sidebar on this. The boot image that you choose for BIOS-based systems is not as important. If you have UEFI systems that will operate in UEFI mode, then the boot image needs to match the architecture of the machine. Haven't tested it for capture. Certainly that's the case for deployment, so it's just a good idea to get in the habit of doing those things. Then you can browse to a distribution point. Oh, oops, there's none for this. Never mind. That's fine. I don't need to actually put it on a distribution point here because I already actually have it created. But you would choose a distribution point, click next, and off we would go to get this created. All right. So let's move to the Windows 8 system and walk through the wizard to actually get this thing captured. Okay, so I'll pull back in my Windows 8 machine. And last time I was here, I simply used the boot media to get into Windows PE. Here specifically, I need to change to capture media. So I have the capture media already created. It's on my desktop, and I'll load it here. Okay, good enough. Now, I'm just going to log in to the test machine. A couple of things you'll notice. First of all, notice that I don't have any domain here. This is a work group based machine. Need to be in a work group in order to capture. Right, so I'll log into this. And then I've got my boot media already located in the drive, so I'll go to my desktop. And if you insert it while the system's up and running, it will auto run and go ahead and execute that way. But here it didn't auto run because I wasn't logged in whenever I put that in. You can definitely tell the auto run statement. So this is the executable that we would auto run. And then this is new in 2012. It wasn't there in 2007, where you can just run this command file to launch the media. It's very simple, right? Very simple little batch file. And then what this is going to do is launch the GUI to walk us through the steps needed to capture the image from the beginning, and then walk through those and reboot us. So we talked about that the steps, the three key ones, while you're in the running OS, is it first can't be a member of the domain. 2, you need to have a ConfigMgr client installed here and accessible. And then 3, we're going to have to do sysprep on the box. So I'm going to tell it a destination. This is where we're going to copy up the image once it's captured. So I'm just going to put it in the root of C, and I'm going to tell it this is going to be capture test win8.wim. I'm not going to actually capture it. I've already got it captured. So the credentials here are critical. We need to make sure that the password and account name are right. Otherwise, we will reboot and try to start the capture and won't be able to actually do anything because we won't be able to get to the network. Right? Good enough. Don't have to fill in anything here. Typically you would. So I'm going to click Next, and off we go. We're going to create this WIM. You're going to notice I'm preparing the ConfigMgr client, and take just a second to initialize that, make sure it's available. And then we will move into sysprep. So we're initializing. Doesn't take long. All right. It should roll over and start to run the sysprep process in just a minute. And there's sysprep, so that's taking place. And then after that process runs, which may actually take a couple of minutes, then we'll reboot, and you'll see a reboot notification. So this progress bar is interesting. It might run across here a couple of times in this process, so just be aware of that. Not necessarily an indication of an error, just maybe taking a few minutes longer, and then we'll reboot when this is done. All right, and then the reboot starts. I'm going to go ahead and click Restart Now. And now Windows PE should be what we launch instead of the OS here, and we'll begin the process of capturing that up to the network. So we'll watch that here. Here comes PE loading up. And then very quickly we'll just start to work on the capture part, and we'll end the demo at that point because the capture can take a few minutes, but we'll at least let it initialize and get there. All right, so here we go, and we're going to capture the machine. We're capturing our volume 1 of 2, and while this is running, if we pull in the site server, which is where I'm staging this, and look at the hard drive, then we should have a file that's there and beginning to be built. So here is, you see I've done this a couple of times, capture test wim8, that's what we named it. And it is in fact coming up to be captured. So at that point, you know that things are running. It's just a matter of giving it time, and we're good. So I'm going to go ahead and turn this off and move this out of the way. All right. So that's basic OSD image capture. It's not hard at all. The system handles itself very effectively. If there are misconfigurations, like maybe your machine's in a domain instead of a work group, we'll tell you that and let you have a chance to correct things before we go through the process in a pretty easy way, right? Build the reference image by hand, start the capture, and you're good. Well, what other way do we have to build the reference machine? Build and capture is a really cool option for building a reference machine. Right? It's possible to do in both MDT and OSD. There is no template for it in MDT, but it's certainly possible to do by creating a custom task sequence in MDT. We do have a default template for it in OSD, which you'll see. Right? The build and capture does exactly what the name says. It will take a bare metal machine and build it with an image that you specify and then capture it at the end. Right? Now, you can either leverage WIM file, the WIM file directly that you already have in place, maybe from a previous capture, or maybe you're going to use the install.wim, which is on the install media, which is a thin image, and build your reference machine from there. That's a very common scenario and a good one to use. Or you could leverage the source files directly. So another option, which is not the default in ConfigMgr 2012, but is doable, is to basically scrape the contents off the DVD, the file contents, store them in a share, and then point your task sequence to that, and we'll install the operating system based on those files, very much the same way as if you were to put a DVD into a drive and boot. Right? So I'll show you both of those. In fact, we'll leverage the source files in the demo that I'll do. Leveraging build and capture allows you to have a fully integrated build approach. So what this means is perhaps you're going to be in a hybrid environment. That's just what you need to do. But you don't want to have the human interaction with the build process. You want it to be automated, to be fully documented because it's in the task sequence and such. So what you can do is engineer the task sequence not only to build the machine, but to customize the machine, add software, drivers, registry keys, default settings, scripts, whatever you need. Right? And then capture the image. So if there's ever a question about how was that reference image built, it's in the task sequence. If you ever need to modify that reference image, you modify the task sequence. Right? With a build and capture task sequence or approach, there is no need for a pre-built reference machine. Yes, you're going to build a reference machine as part of the process of using build and capture, but you don't have to do it yourself ahead of time. Right? The build and capture process will do that. And that's the beauty of it. The task sequence, very controlled customization during the build. It's the same every single time, and it's a pretty good experience. So let me show you the build and capture task sequence. To do that, I'm going to pull back in the lab environment and walk through that portion of it. So just like we had our wizards for building the task sequence media, now we have a wizard to build our task sequence. Remember, the build and capture is a task sequence that we need to use. So most people think, and they're right, that a task sequence is to install an image or to create a virtual hard disk or something you're going to deploy the image. That's true. You can use task sequences for other things too. Certainly you can use task sequences to build and capture your reference machine. You can even build a completely custom task sequence and use it for non-imaging purposes. Right? But for here, we'll do a build and capture task sequence. Click Next. Okay, so we'll call this test build and capture. Again, I have one already, so I'm not going to save it. And then, like any imaging task sequence, you're going to need to specify a boot image. So here, I'll just choose I'll choose x86 here. Boot image. Okay. Click Next. And I'm going to choose what image package that I want to use. Now let me call this out. So this, when you browse to it, it is going to only present to you the WIMs that have been imported under operating system images. The wizard will not allow you to choose operating system installers, though you can actually do that once you get the wizard built, should you choose to do it. Because the install.wim is so convenient, this is really the default that most people go with, but you can do it either way. So I'll choose my Windows 8 Enterprise. Here's the piece. Again, I'm just going to move through here because I'm not going to save this. I'm going to say be in a work group here. You could choose a domain if you wanted to, but this is just a build, so why put it in a domain? We need the ConfigMgr client. I could include updates here if I wanted to, but I won't. I can install applications if I want to, and then any sysprep files, and then off we go to capture the image. I'll place a path here to where I want the image to be stored. So I'll break out of this here. So if I were to finish the wizard, I would have a build and capture task sequence, very much like what I have here. So this may look similar to what you saw in MDT for the sysprep and capture. And there is similarity because they're both task sequences, but the build and capture doesn't I'm sorry, the sysprep and capture in MDT doesn't build the machine, it just prepares it and captures it. Just like our capture media did in OSD. The build and capture will actually build the machine and then capture it after it's done. So what are the key pieces here? First thing is restart in Windows PE. So there's no requirement that you actually start this from bare metal. You could, in fact, deploy this and start it from a running OS. Typically, you don't, but you could. If you're in a running OS, then we'll detect that and restart the machine back into Windows PE, which is where all the goodness takes place. Right? Then we have steps to partition the disk based on whether you're BIOS or UEFI, and then the apply operating system step. So here is where you see the choice to actually use original installation source files. So if you go over here, let me break out of this. Notice the name, Windows 8 Enterprise, right? Windows 8 up here. So if I go to my operating system installers, you will see Windows 8, right? If I were to actually go to the path that is being pointed to here for data source, it would be a folder that contains the files that you would see if you were to open up a DVD and look at the file structure. Right? This is what you would see if you just simply put in a Windows 8 DVD to the drive and opened up Explorer. That's what you would see. So in this task sequence, I am specifically going to install the OS from my source files. I could just as easily use the operating system image WIM that I'd imported before. Right? Apply my Windows settings, any network settings, apply device drivers. So this is really cool to make sure you have your drivers up to date for the image and so on. Here's where the ConfigMgr client gets loaded. And then we're done. We've fully built the machine. If you want to add some things in here, to add applications, to add scripts, to add registry hacks, whatever, you can very easily build this out. So once we're at this stage, we're done. So now we have to prepare the system to capture. Here's preparing the OS. We're going to actually run sysprep at this stage, and then we're going to capture the reference machine, and here's the path we're going to capture it to. All right? So let's actually see this in action. Like anything, if we're going to run on a machine, we have to have a deployment. If we're going to send a task sequence to a machine, we have to deploy that to a collection where the machine is located. In this case, this is a bare metal VM, so it's unknown to ConfigMgr in its current state. So I'm going to deploy to all unknown computers. More about that as we get deeper into the series, the way to handle unknown computers versus known computers and so on. Right? Okay, so let's go over and pull in our bare metal VM and boot it and see what it looks like to kick off at least a build and capture. Actually, let me spend a minute here before I launch the build and capture. So the machine that I've been working on to this point is my Windows 8 test machine. Well, you see Windows 8 here. My test machine called Windows 8 is known to ConfigMgr because you see it in the database here, or in the device list here. My deployment of this build and capture task sequence was to the unknown computers collection, meaning there is no record in the database for the virtual machine that I'm going to build or boot from. And you'll see that the system I'm choosing now is called bare metal. It is one that does not exist in the system. If I were to simply choose the same Windows 8 system I've been messing with and boot it from boot media, it would never find the task sequence because that task sequence was not deployed to the Windows 8 system. It was deployed to all unknown computers. Hopefully that makes sense. If it doesn't, we'll get more into it later. But let's go ahead and start the virtual machine from now. Actually, let me make sure I have the right DVD. I do. And let's go ahead and start this up. So I'm going to press any key to boot from the DVD. And let's see what task sequences we have to run. All right, so I simply click Next. We go out and look for the task sequences, and lo and behold, here is build and capture. So I want to build this and capture it. Oops, what happened? Oh, yeah, I need to get that on the distribution point. Sorry, let me do that. I'll be right back. Okay, so now we have the information on the distribution points, a lot better experience, and off we go. So the task sequence is running. It's going to lay down the operating system, do any customizations you specify, reboot, capture it, and put it on the share. Right. So that's the build and capture task sequence, at least the beginning part of it, in operation. Okay. So let's continue. So the other thing, actually, let me go back to the PowerPoint for a minute. Pull this back out. So the last thing that we have to talk about in terms of being able to obtain the image is the install.wim. So I've mentioned several times through this that it's very common now to use the install.wim directly, right? Instead of having to go through the whole process of grabbing a reference image and so on, especially if you're using a thin environment. It's very easy to just grab the install.wim. It's about as thin as you can get and use it for your image. Couple of comments about this. So ultimate thin approach, you can't get much more thin imaging than that. There is a challenge with this though. You cannot update a install.wim that you've imported offline. Well, what do I mean? Well, before I show you what I mean by that, let me finish this up and then I'll take you back to the console and show you what I mean. There are some challenges in some cases with drive letter choices or which drive letter actually gets chosen for the image when it's laid down, specifically in Windows 7. So in Windows 7, the install.wim that was captured and put on the media was actually captured from a D drive. And that D drive is preserved in that WIM file. So if you simply grab the install.wim and load it that way, then the resulting operating system will be on the D drive. That problem doesn't exist in Windows 8 forward, but it did in Windows 7. It's not really a problem. You can deal with it. There's actually a variable that you can set if you really don't want it on the D drive. I mean, the OS is fine on the D drive. It really doesn't matter. But it's common to have it on the C drive. So if you'd prefer to have OSD ignore the drive letter from which the WIM was captured and stored in the WIM, you can use a task sequence variable called OSD preserve drive letter and set it to false. By default, it's set to true, so we will just simply replicate whatever drive letter was in the WIM back onto the system where the WIM's deployed. But if you don't want that, if you want us to just put it on C as an example, you just manipulate the variable and you should be good. Again, OSD preserve drive letter. The install.wim, it's really easy. If you're going to go that way, then you don't have to, again, worry about setting up reference images and capturing those things. Yeah, you could use it in the build and capture, but you don't have to, right? So it's up to you. Now let's go back to cannot update offline. So in OSD, we have the ability to actually inject updates into the systems or into the WIM files offline, right? So most organizations will do some base level of maintenance on their WIM files to make sure that the updates that are made available actually make it into the WIM files as well, so that when the image is deployed, the patch level is at least reasonably current. Right? It's really easy to do that in the OSD nodes here. You simply schedule an update, and I don't think I'll have any show up here as far as updates that I can pick from, because this environment's not one I use for software updating. But if one shows up here, or two or three, or however many you want, you choose it, and then the system will automatically go and inject those updates into the WIM for you. So it's a real convenient way to keep your WIM up to date. The challenge is that process will not work with the install.wim. This won't even be available. It will be grayed out. Right? So while that's a bit of a inconvenience, it's not a showstopper. You could just make sure that the install.wim that you're leveraging is updated as the various service packs and R2s or whatever come out for a given OS. And then you'll be reasonably up to date as far as patching, right? Once we integrate Service Pack 1 into the media or Service Pack 2 into the media, you can grab that install.wim and it will be an updated install.wim, at least to that Service Pack level, and then any updates that need to go on will be after that, right? Okay. So since I'm here, the last thing we do if we once we get the WIM is we have to import it. Importing the WIM is extremely easy. It's just simply a matter of going to this node, and you see I have done a couple. I'll just get rid of this and import it again. It's simply a matter of right-clicking, Add Operating System, and telling it the path. You have to be in UNC format. And here I know it's just called capture.wim. And I import it. And once I import it, it's like any other content that you have in ConfigMgr. You would put it out on a distribution point. You would make sure that it's accessible where it needs to be accessible, different things, right? And then you're good. So that is a review of the various processes, procedures that you can use to capture your image. At the end of the day, what your goal is to get a WIM file, and then that WIM file can be used to deploy to your environment. And that's where we will end the discussion for today. As we go forward in future sessions, we'll start digging into how that deployment process actually works, starting basic and getting complex. And so we'll pick up in part 3. See you then.